Good day, eh? Today we are going to be adding an I2C LCD to our project, where we will be setting up and testing the LCD and then incorporating it into our project. So not only will you be able to set up your screen, but hopefully you'll be able to add it into your project. I am not an expert on Python or the Raspberry Pi. I hope someone will benefit from the projects I do, and hopefully the guides and how-tos will help them with their project. All code from today's episode will be on the GitHub page posted in the description below, as well as any links that might be needed throughout today's episode. Feel free to post any questions or comments below. If you have an idea for an upcoming episode, make sure to let me know as well in the comments section. So with that being said, let's dive into the Raspberry Pi. Okay, so we have our Raspberry Pi hooked up here once again to our GPIO. So as you can see here, I have my I2C wired up here on the back of my screen here. And I have this going into my 5 volts on the Raspberry Pi over here. Hopefully this will pick up. There we go. Here, we'll go like this. The black wire on here, that should be my ground wire. And that is going over to the ground on my breakout board here. And then the next one is going to be the white wire, which is going to be my power. So I've run that over to my 5 volt rail here. And down below it there, we should have our SDA1. And then that is going to go over here. It might be a little hard to see. Sorry about the let me see if I can get that a little bit better. But it'll be right over here. And then this purple one here coming off will be our SCL1. So we're going to plug that into here. So you'll see SDA and then SCL. And those are the ones you're going to want to plug in from there. And on the back of your screen, it will have it labeled there of what they are to where they're supposed to go onto your Raspberry Pi or your breakout board. So let's go ahead and let's bring up the Raspberry Pi here and take care of a little business of finding out where that screen is on our Raspberry Pi. So all we're going to do is click File, and then we're going to go New, and we're going to go to Python File, and then we're going to name this I2C Detect. And like I've said, you can either put the Pi extension here, or you can just leave it blank like this, and it will automatically add the extension on to your file. So now we're on the I2C Detect here. We have not much going on here. We're going to write a little bit of code to find out where the I2C is on the Raspberry Pi. Oh, I'm just going to go import OS, and then we're going to go import sub process, and then we're going to import time, and then we're going to go p equals, and then sub process dot poppin. There we go. And then, oh no, we don't want curly brackets, we want that one there. And then we're going to go I2C Detect, and then comma, and then another one of these guys, negative Y, next space, another comma, and then another one of these, and 1. Oh, what's going on here? Oh, there we go. And then we'll go to the other side of that, and we'll go comma, and std out equals subprocess dot pipe, and then we'll go like that, and then okay, and then we're going to go for I in range, and that's going to be 0,9, and then go like that, and then line equals str, and then that, and then p dot std out dot read line, and we'll go like that, and then we will go print line. And now with our I2C device connected, and if we run this, we should see something happen here. So I'm just going to right click on the screen here. And then run I2C detect. And oh, did I make a mistake? Talk about making mistakes here. So, oh, I wonder if I have I2C disabled on here. So all I'm gonna do is go and check that here. So Raspberry Pi, sudo Raspberry config, and then interface options, and then I2C, and then yes, we want to enable it. Then OK, finish, and then exit, and now if we run it again, now we get our output. So now we can tell here, let me just bring this up here, that here is our LCD screen, is 3F here. So how are we going to write that when it comes time to program the Raspberry Pi screen for there? So that's going to be 0x3F on that one. Okay, so we would write it like 0. Alright, I'm just gonna, so I2C LCD equals 0x3F. So this is what we're going to need to use in our upcoming code here. So I will leave this, once again, check the files there in the description there, and you'll be able to check out this code here as well, and you can use it to find out what your I2C address is for that. Because yours might be different if you are on an older Raspberry Pi. The only thing you would have to change, I do believe, is this 1 here to a 0. So if you're on newer Raspberry Pis, this will work like this, but you would want to change this to a 0 if it's not working after that. Just so you know, you probably are running an older Raspberry Pi, but you'll be able to detect your I2C port. So now that we've done that, the next thing we're going to want to do is we are going to want to get the LCD driver for this. We're going to go and open a web browser, and we're gonna download some code. I want to, while that's loading there, I want to create a new file, and we are going to create another Python file, and we're going to label this one I2C LCD driver. Okay. Now we can bring this guy down. We don't need to see that right at the moment here. Okay, so I'm just going to bring up the page here. So this is the page that you're going to want to check out. The link is in the description, and I will have all his information on the LCD driver and on the code as well. I won't be removing that. That's all his stuff. So all we're gonna do is we're just gonna scroll down. None of this, we've already gone through all that stuff. So this is the code here, and we're just gonna take this code from here. I'm just gonna copy it all. So what this is basically going to do is allow us to call the information from this Python script here to control our project, the LCD on it. So we're just going to go ahead, we're going to bring that down, and we're just going to take that, right click, we're going to copy, go back to our Python driver and paste that there. There we go. So there's 179 lines of code, and all we're going to do is we are going to go up to the top here. So if you, like I said, if you're on the original Pi, you're going to be using that 0, whereas on the Raspberry Pi reversion 2, that's basically your newer ones, you're going to be using that 1. So on our I2C detect here. So this would be a 0 to check. So now all we're going to do is, because we're on a newer Raspberry Pi, we're going to update that I2C bus to 1. And then over here, this is where we want to change that address. So ours was 0x3f. That's it. We're done with this document for right now. So the next thing we want to do is we're going to create another document. I'm not going to go on anymore with this document because there's just a lot of stuff here that we don't really need to worry about right at the moment here. This is just to get you up and running, right? So now we'll go to File, and then we'll go to New, and we want a new Python file. So I'm using the 4x20 LCD module. So basically, if you're using the 2x16, it's going to be the same, but I'm going to set this up as if I was using it for my screen. So that way you can just not do a couple of the parts and everything will work for on your screen. I just want to fill it up. I don't like a blank screen, so that is what we're going to be doing there. So back over here, all we are going to do is we're going to label that I2C I'm going to put 4x20. You can do whatever you want for yours. It's not going to matter. LCD, and then hit enter. Now we have our new document here. So what are we going to do now? Well, we're going to use the simple code that was there. So import, and now we're going to import that driver that we just made. So instead of doing the pip3 install, we have created the file to pull that information from. So it's going to pull that information from that I2C LCD driver. So we're going to import I2C underscore I2C underscore LCD underscore driver, and then from time import, and then that guy, we're going to come down and we're going to go my LCD equals I2C underscore, and then now it started, so we just have to press tab. So now you can see where that is referencing from there. And then all we're going to do is write our lines of code that we want to have in there. So if you are using a 2x16, you would only do this next process 2 times and not 4. So we're going to go my LCD.LCD underscore display underscore string, and then we're just going to put hello world, and then we need to tell it what line we want that on. Now there's going to be a lot of things we can do to adjust where it places it on the LCD, as far as the line spacing, if we want scrolling text, all that kind of fun stuff. But you can play around and kind of learn that on your own. Read the driver library. You're going to find some interesting things in there that you can do as well, what this is capable of, and check out his GitHub page and that kind of thing, and see what else you can do with this driver. Now, I'm going to say this right now. You don't have to use this driver. You can use a driver from the pip library there as well. So if we go File, and then go to Settings, and then we go to here, and then this is all the stuff that we have loaded. If we go to Add, in our search here, we can search for I2C, and now right here you can see a few of them named LCD throughout here, right? And you're going to be able to kind of go through whatever. I'm pretty sure there's more around somewhere, but let's go to I2C LCD. So it's going to give us the information of what we are looking at, what the LCD model number is here with the I2C adapter for Raspberry Pi or other device. So right here, it's going to have a link to their GitHub page, and you're going to be able to look at their sample code, and they're going to usually have a ton of examples of stuff that you can do with it. So you're open to a lot of opportunities of what you can do with the LCD screen. So I'm just going to close that out, but just so you're aware, that's in the Python interpreter, and then we're just going to click Add, and this is basically doing that pip install on here as well. But if you don't know what you're looking for, then this is the best route to go, is to look through there and see what you can use from the library there. Alright, so let's close that guy out. Okay, so line 1 is done here, and then I'm just going to copy this, and I'm going to copy it 3 more times. So paste, 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 and then all I'm going to do is change the line numbers here. So this is the lines on my screen here. So each line should say hello world. So I'm just going to go ahead and bring up here. I'm just going to bring up this guy here, and I'll see if I can zoom in just a little bit here. Let's see here. Hopefully that looks good. We'll find out here in a moment. I'm gonna go ahead and run the code here. That's all there is, and we should be able to display text on the screen here. Oh no. Okay, there we go. I forgot a little bit of information there. Now we should be able to run it. So we're gonna run that guy. And now on my Raspberry Pi, you should be able to see Hello World printed on it. But for some reason, it's pretty dim, and that's probably largely because I am using too much power here. Alright, so that's just gonna have to do for now. You can see it says Hello World on there. We've got it printed 4 times. Now I wish I had a proper power supply for this. So give me a second here, and I'm gonna try a different power supply on my Raspberry Pi, because I'll show you here. Right now all I have is micro USB to USB-C, and it's obviously not doing the trick. So I might have to steal the power supply from back there, but that's okay. Okay, so now I've got everything kind of adjusted here. Let's go ahead, let's run this code one more time here and see what happens on the screen. There we go, that looks better. So I definitely had an issue with power consumption causing my LCD to not output the characters brightly enough. So now we've got that taken care of. So now we can move on to our next step, now that we've gotten this working. Okay, so we're going to create one more document. Look at that, we're just getting a whole library of different things now. And the great news about that is we have something that we can reference later on down the road. And you can save them, close them out, and then be able to have a list of all your projects and files right there on screen. So that way you might want to pull information from one of them, you have them down the road there, and you're going to be able to use that. So now we're going to go ahead and we're going to create a new document. So file, new. Once again, we're going to create a Python file, and this time we are going to use that DHT sensor that we used last week, and we're going to get that outputting some information here. So the first thing we're going to do is call this DHT I2C LCD, and then hit enter. And now we have a new file. So what we're going to do is we are going to go to our DHT11 with LED status here, and we're going to select all this. Yeah, so I'm just going to copy all this stuff here. Copy. And we're going to go over to our new document, and we're going to paste that in there. So now that we have this here, we went through last time how to import the Adafruit DHT, and that's where we were getting our stuff for our DHT11 sensor. So now what we're going to do here is we're going to just add import, and then our I2C LCD driver. Look at that, it comes up now. And then we are going to go, that's all right there, that's there. And we want, there's the DHT sensor. So now we remember from our library on the this one here, we have this guy here. So we're just going to copy that and we're just going to paste it somewhere around here. We're just going to paste that guy into there. So previously on the screen here, we had to import time, and we already have that in there, so we don't need to worry about that. So all we're going to do here is we are going to leave all this stuff here. We can change durations of our sleep and stuff like that, but we want to keep all that kind of stuff the way it's meant to be there from our original code. And all we're going to do is add a little bit of code here. What we're going to do is we are going to start with this is going to read our printer temperature. So what we're going to do is we are going to print the temperature in our output here. So we want to keep that, but I'm going to bring it down one. And what we're going to do is go my LCD.LCD underscore display string. And this right here is where we're going to copy this information here, and we want all this stuff except for the outer brackets. So I'm just gonna copy that, paste that in there. So now for me to display this on an LCD on one line, it's not going to fit. It's with the temperature and humidity both typed out like that. So I'm just going to reference this as temperature equals T. So that's what temperature is, and humidity is just going to be H. I'm pretty sure that should be good enough. And we now need to tell it where we want to output that data. So we're going to output it on line 1. And then on line 2, we're just going to go my LCD.LCD display string. And then we're going to put sensor OK. And then I'm just going to put, about that many spaces there. And there's a reason why I'm doing this, just so I don't have to clear the LCD all the time. It's just going to overwrite any remaining data from what I'm going to do when the sensor says failure. So this is just going to put blank spaces and kind of clear itself out on its own. We could run an LCD clear every time, but the least amount of flashing I can have my LCD do, the better. I like it to look nice and smooth and fluent. So we're just going to put, this is number 2. And then we're going to go time.sleep. And I'm just going to set this to 1 second. And then I'm going to do the my LCD.LCD display string. And then right here, I'm just going to go, because you can stop at those 2 lines above there and don't bother with these next 2 lines. Once again, I don't like to see empty space, so I'm going to put I2C LCD and DHT11. That's it. That's going to be my line 3. So once again, my LCD.LCD underscore display. Hit the string there. I'm hitting tab button, and then I'm just going to put my branding on the bottom there. And that's it. So I've got that set the way I want it there. Now we're going to go to the else statement here. And regardless, you can have this statement here be your if statement, and then your if statement right now up here could be this. So you can swap them around if you wanted to. All depends on how you want to write your code. It's going to output the same way. So now all I'm going to do is, so we're going to do the sensor failure here. So all I'm going to do is my LCD dot, and then we're going to do the display string again. Do our sensor failure, period, and then we'll come over, comma, this is going to be line 1. So you could put, you know, you could print check the wiring or whatever on this line or whatever you wanted. I just did it short like this because whatever's left over here from this sensor OK here, it's going to display it on the same line. So I need to wipe out any remaining characters that are going to be put on there. So we're going to come back down here. So that should work. We'll find out, right? And then LCD, and then display string again. And so I'm actually going to display that on line 2, right? Because we don't have any, so there's a reason why I'm going to do this. So whenever an error occurs, it's going to at least leave the last known reading on the screen on line 1. So now I'm going to go ahead and do line 2 or line 3 and line 4. So I'm just going to do that I squared C LCD and DHT11, and then that's going to be my number 3. And you probably could leave this out if you wanted to, but I'm going to put it in. You can play around with it on your own and see what kind of outputs come out of it. Okay, so I've done that. So now we have line 1 printing our temperature and humidity, but if there's an error, it's not going to. We have our LEDs that are still gonna display if it's collecting information or if it's in an error state. So what I think I'm gonna do is I am going to change the output to 0.5 on here. We'll make it a little shorter. I'm gonna bring this over here and put 10 seconds there. So this should, I do believe, should do a check every 10 seconds now if I do it that way. So this is gonna do the high low, and this is just gonna flash on and off if there is a failure, but it's gonna do the flash. And you could change if you want the error to be more or less or whatever you want. You can play with that as you want, but this is basically it. So we've written a fairly, well, a massive program, but it's definitely a program where something's going to happen. We've used our own LCD driver that we've copied the library from, and you can check it out and you can build your own, edit it to your needs as well. And we're using, an imported with pip3 driver with the Adafruit DHT, and then some Raspberry Pi GPIO output with the LEDs. So we got a lot of things going on here in just one little simple project here. So what I'm going to do now is I'm just going to bring up my display here again, and I'm going to make that a little bit bigger here just so you can hopefully see it. Now the LED is just visible on the bottom there. I guess I could zoom it out just a little bit here, maybe make it a little bit more viewable. Let's see what we can do here. I don't know if it's gonna be a little bright on the screen or not. Let's go something like that, and then see if I can get that. There we go. Okay, so we've got that all done. So I'm gonna go ahead and I'm gonna run this now. So I'm running it now. So I'm gonna run it from here because that's the way we do it. So sensor failure, check wiring. Oh, what did I do here? So I have something reversed here. Do believe line 1 should be, let's try inverting. So this is what I'm gonna invert that and see what happens. So why is that printing? Oh, I didn't set which line to put. I want to see if you can see this or not. Okay, so I'm just gonna go like this here. Hopefully, let me just check here. Okay, as you can see here, I didn't state what line I wanted that on. So I want that on line 4, so I better get that put onto line 4 because we're just hiding our sensor data here that should be printing on the top line. So once again, I'm just going to go like this, and obviously I didn't do it down here as well. That's how easy something can become messed up. So remember, now it looks like this is going to be the failure part, and this is going to be the OK status here. That's what happened when I inverted the code here. So we can invert if condition if we want. So this is going to invert this lot here down to here. Okay, let's retry that. Let's run that module again. And now we've got the sensor failure. And you can see that on, I hope you can see that. Yeah, you can see that on the left there. And now you can see that we are reading some data there. We've got 20 degrees Celsius and 33% humidity. And now it's going to log it. It should be every 10 seconds. And there we go. We've got a fully working project. And we've created quite a few documents, and we can reference these in the future for upcoming and future projects. So it's definitely something to play around with and get the hang of. Once again, like I said, I am not an expert on Python or the Raspberry Pi. I just love playing around with them. We've got our LEDs blinking from our original LED on off to our DHT11, and then our DHT11 with LED status. And now we did the I2C LCD, and now we've done the bigger project, which now it sounds really cool because we have a DHT11 on an I2C LCD with an LED status light. So it's a lot more all wrapped into one, and sounds like a cool project to me. That comes to the end of the project here. So I hope you enjoyed it. Make sure to post any comments in the comments section there, and let me know what you thought of this project. Once again, there's always room for improvement, and I'm definitely willing to learn more of what you guys might be interested in, so let me know below. I just thought I'd mention this. If you look at the, let's bring up just this guy here. So now you're going to see the sensor failure. Now this is where on that sensor OK that I decided that I would put those blank spaces, and that is where it's wiping out any of the other stuff that was printed there, because if I remove that from the code, then it would still say some leftover characters on after the exclamation mark there. It would basically say LURE and then the period, but we wanted to make sure we wiped all that out. Oh, I guess it helps if I spell my stuff right here as well. There we go. So I'm going to show you here quickly what it looks like if I remove that those, I think, 5 spaces from that sensor sensor OK there. So I'm gonna do that, and I'm gonna run that right now, and now we should see the sensor OK, and we're gonna wait till it goes to failure and then back to OK, and you're gonna be able to see what I mean by it leaving those extra characters afterwards. And then I'll put back the actual code the way it should be here, so I can upload that for you guys. Okay, so now we have that sensor failure, and now the next one, it should leave some of the characters there. There we go. So we have the lure period left over there. Stop, rerun. Now after that, it should go back to OK. So now that we've removed that, it's now OK again. Alright, that's it. So thank you for watching, everyone. You have a wonderful day, a wonderful week, and we'll see you next time. Take care, eh?